Hey everybody, I'm Chili. Welcome back to Beginner C++ Tutorial 22. Today we're talking about enumerations and switch statements. So what is this bullshit? Well, back in Tutorial 21, we created an array of bools to represent our 2D grid of cells. And that bool array represented, which cells contain obstacles. Then in the homework, we extended that so that the cells also can represent food or poison, but because a bool only can represent 2 states, whereas here we'd have 4 states, empty, obstacle, food, or poison, we changed it from bool to int. So now we have an array of integers, and the value of those integers represents what is in any particular cell. So far, so good, except the fact of the matter is we have these numbers that represent the contents of the cell, and that's kind of fucked up because, look at game.cpp here. We want to spawn some contents in a cell. So this is going to spawn content 3, which is poison. This one's going to spawn food, I believe, which is 2. This is very easy to fuck up. Imagine now your cells can contain like 20 different things, and you've got to remember, was that 22? Or was that 21? Or was it 12? Fuck, I can't remember. And you fuck it up, and then you're fucked. You gotta debug a bunch of bullshit. It's gonna be hard. It's gonna be a bad time. It's no good. That's what I'm saying. Just setting these numbers to mean something and then putting your numbers in your code like this. This ain't self-documenting code. What the fuck is 3? Someone reading this is gonna be like, what the fuck is 3? What is this bullshit? What is 2? What is 3? I don't know. Fuck it. Just fuck it. I'm saying fuck a lot today. Anyways, so I got a solution for you. We're going to create a new type that is just to represent the contents of a cell. So how do we do this? Well, let's create a new section here because that's what I like. This part is optional, by the way. And the thing we're going to create is called an enumeration. So we type enum. Then we type class because reasons. And now we type the name of our new type. So let's call it cell contents. All right. Now, just like classes, you got to put in the curly braces. And now it's time. You don't have to put public or private. Everything is public. There's no public and private in an enumeration. Now you type the names of the values that you want to be possible for this new type. So values will be empty and obstacle and food and poison. There we go. So we got 4 different values that this new type can assume. Now we can use this type to create an array of cell contents. But now we can't initialize them to 0 because 0 isn't one of these things, right? 0 is a fucking number. This is a cell contents. You can't just jam numbers in there. So we want to initialize this fucker to all empty. So we put empty. And you see, right away, the compiler tells us what the fuck is empty. I don't get this because empty is a value of the enumeration cell contents. So you got to put in here cell contents empty. And if you do this, the compiler is going to be like, oh, dude, that's cool. I know all that. And it'll initialize your array to all empty. And this is much easier to read than just 0. Just put everything 0. It's all 0. No, this is way better. Now we don't need this dumb comment here to remind ourselves because that doesn't, wait, what? Delete. There we go. Okay. So that's good. Now we just got to fix our shit up where our shit needs fixing. So if we go into this one here, we're going to get problems. So return contents, blah. So it's not going to return an int, obviously. Let's go back here. Let's go back. So consume contents, that's fine. Get contents. This is going to be cell contents, right? It's going to return contents. Spawn contents is going to take contents. So cell contents. There we go. And what else? I believe that is it. I could be wrong. We will see. What is your problem? Oh, these aren't matching the fuck. They aren't matching the fucking thing. So this has got to be cell contents here. Cell contents. And that should make this red underline go away. All right. I defined cell contents inside of board. So it's a part of board. So unless I am actually inside of board for the code I'm writing, and this code here is outside of board, right? once we get inside this function, then this code is part of board, but this is still in the outside part. So I got to specify that I want board cell contents. So I go board cell contents, and that's good. That should be fine. There we go. And now it doesn't hate me anymore, and that's good. Consume contents here. So we can't compare this with 2 because fucking that doesn't make any sense. We got to compare with cell contents. And so it's got to be either food or poison. Those are the only 2 things that you can consume. So cell contents, poison. There we go. All right, let's just... yeah, let's put that over there. It's all good. And here we can't set that equal to 0. We've got to set it equal to cell contents empty. And this already is way more readable. Now we can understand what this fucking thing is doing without having to know ahead of time what those damn numbers mean. Okay, spawn contents is going to need a cell contents. And you see here, this is already inside, considered to be inside of the board class. So I don't have to put board cell contents. Whereas here, I've got to put it because it's outside of the class. Inside the class, you don't have to specify board, right? All right, so here we go, and we make sure it's not equal to cell contents empty. And that should be... there we go. Here is good. Where are we at? So get contents. It's not an int. It's a cell contents. Say it after me. There we go. Now we can't compare we can't compare this with numbers. So we got to put in here all of the things. And you do that. It looks like this. All good. Now game.cpp. Let's go to game.h. Make sure there's nothing weird in there. I don't think anything will change here. No. So game.cpp is obviously going to have some problems. So here we're going to... we're going to be spawning, what is this? Poison and food. Notice that this is not inside of the board class, so I have to specify board, cell contents, poison. But one thing I've just noticed here is I fucked up in the last video, and when I created this loop to spawn the food, I didn't get rid of this single spawn line here, so this is not supposed to be in there. Let's just fix that right now. You saw nothing. And all right, so here we got to put this one as board cell contents, like so, and then we've got to replace these magic numbers with enumeration values. And that's going to look like this, and I believe this should build, but I could be wrong. Let's see if the compiler complains. It does not, and the code works just like it did before, only it's way sexier now under the hood. All right, good. All right, now a couple things before I move on to switch statements. First of all, enumerations, the actual data that stores the different values, it's just under the hood, it's just an integer type, just like when we were using ints before. In fact, it defaults to just your normal int. That means that by default, every enumeration variable can store at most about 4 billion different kinds of values, so 4 billion of these guys. And it takes 4 bytes. If you don't need that much, in most cases, just leave it as the default. But in some cases, if you don't need that much and you want to conserve space, you can do something like this. You can go enum class cell contents and then do like short. And what that'll do is that'll make the underlying type, the thing that backs every one of these, short. And a short is a 2-byte integer. It can hold about 60,000 different types of values. Or you can make it a char, and char is a 1-byte integer, and it can hold about 250 different values. So in certain situations, it might be useful to change this, but normally just leave it as the default. Let the compiler choose it for you. Now, because the underlying type of an enumeration is the integer, that means that the underlying values of these must be integer values. So what are the values? Well, by default, it's going to give these numbers 0, 1, 2, 3, etc. But if you want, you can assign values yourself. And you do that like this. You set up the values with the equal sign, and you just say this enumeration value will be represented by the integer 0, and this one will be represented by 69, whatever. So you can do that, and it's useful in, again, some situations. But in general, if you don't have a reason to, just leave it at the default. All right, so oftentimes when you're working in situations where you're using enumerations, you've also got code that has to check the value of an enumeration variable and take different actions depending on what that value is. And it's going to look like this. It's going to be a chain of if, else, if statements. Now, there's a different way that we can represent this, and it's called a switch statement. So how is that going to work? Well, you type first switch, no big surprise there, and then you've got this thing, these parentheses, just like you have for the if. And this is where the value to switch on is going to be placed. So we want to switch on the value contents. So we put that in there. And then we do our curly braces. And here's where things get very different. Try to spell contents correctly. There we go. All right. So you've got different cases, different values that this thing could be, and you want to handle those cases. And the way you do it is you go case, and then you type the value of the case you want to handle. So this is going to be, so board cell contents obstacle, and then you put in a single colon, and now you put the code that you want for that case. So it's going to be draw cell with the value obstacle color. So put that in here. And at the end here, you're going to put in a break, and that's very important. You have to put a break at the end of all these guys. Forgetting the break is a huge source of bugs in people's code, so don't forget the break. That's my PSA for today. Don't forget that fucking break. Okay, so you've got one case for the obstacle. Now you do the same for the food and the poison. Now when you're done, it's going to look something like this. Let me delete this if-else chain here. And the way it works is, you enter the switch statement here, you switch on the contents, and it will jump to the case label that the value of contents is. So if the contents value is going to be, what is it going to be? Let's say food, then when you hit the switch, it's going to jump to this, it's going to execute this line of code, and then it's going to break, which is going to exit the switch statement. And if it's none of those, if it's empty, then it's not going to enter any of these cases. It's just going to automatically exit the switch. Now, let's say I want it to do something if the case is none of these guys, if it's something else. For example, if it is empty, you can add, there's a special case label called default. And if I put stuff in here, this code will be executed if it is not any of these guys. Now, remember I said always put the break at the end of a case label. And that's almost always true, but sometimes you might want to omit the break. Consider the case where you want food and poison to do the same thing, to say draw the poison color. You can do this. You can get rid of this stuff. And in this situation now, if the switch hits a food, it's going to jump here and execute this code and break. If the switch hits a poison, it's going to jump here, execute the same code, and then break. So you can, for example, omit the break if you want multiple cases to execute the same code. That's just one situation where you might want to omit the break. But usually, you want that shit in there. Now, you might be saying, oh, Chili, these switch statements are looking fucking sexy. I'm going to use them all the time. But no, you can't. Switch statements are not a replacement for if and if else. First of all, switch only works with integer types. Like, take a look at this. So I create a float here and I try to switch on it with a couple of float cases, and it says expression must have integral or enum type. So you're fucked. Can't switch on a float or anything else. Only integers or enumerations, which are, as you know, integers under the hood. And there are a bunch of other restrictions, like, for example, the integers for the cases. These cases must each be an integer value, and it has to be known at compile time. So you can't put variables in here and expect it to work. It has to be compile time constants in the cases. So the switch has to switch on an integer type. The cases have to be compile time constant values. And that's about it, I guess. Now, one more thing. If you try to create a variable inside of a case like this, you're going to get an error. But you can fix that by basically just creating a new variable scope inside of the case here. So you can put some curly brackets here and some curly brackets here. And this will get rid of this error here. Initialization Z is skipped by case label. If you do that and you build it, then it works fine. So if you want to create, local variables inside of a case, you've got to add these curly braces to create a scope for them. In fact, I don't really see any reason now of creating a variable to store the contents, since it's just going to be switched once. So I might as well just copy this here, put that there. and get rid of this. This is even better. So switch statements are used generally in a situation where you've got some kind of integer variable or enumeration variable type, and you want to conditionally execute some code depending on what exact value that variable has. I don't use it that often, but I tend to use it when there are a lot of options as to what it can be. Like, for example, take a look inside of the framework in the main window code here to handle Windows messages. So Windows can send a whole bunch of different messages to your program and you can respond to them. And the way I do it is with a switch. So message is just an integer type and I switch on it. And if it's, these are just macro definitions, # define, and they define as some value. And I'm switching on the message that's passed in from Windows, and depending on what it is, I do some different things. If it's a keyboard message, I update the keyboard class to put the information in there so that you can get that information in-game. Or if it's mouse, I put that information into the mouse class. What else is there? That's about it. Mouse, it's basically just mouse, keyboard, and some things for if the window is being destroyed. That's it. Now, I often get the question, when should I use a switch and when should I just use if else? And I mean, basically it boils down to what is going to make your code look better, make it easier to read, make it more maintainable. If you think a switch will do that for you, use a switch. Otherwise, just stick to if else. Generally, when people ask that question, they want to know, which one is going to be more performant. And honestly, don't fucking worry about that kind of shit. One of the big traps, and I'm going to get a little into dank chili mode here for the end of this video, but one of the big traps that beginners fall into is what I call NOS and micro optimization. So what's NOS? NOS is newbie optimization syndrome. That's when newbies start stressing out and thinking about things that have no effect on performance whatsoever. Like, let's say they see a line of code like this and they're like, oh, well, if I do it like this, it's going to be faster because now it's only one statement instead of two. No. The compiler is going to give you the same goddamn code for either of those cases. It doesn't matter one goddamn. Just write the code that will make the code easier to maintain and understand. Now, micro optimization and premature optimization is where you're making changes that actually will affect the performance, but you're doing it in a very stupid way. Like, for example, there can be situations where a switch statement can be faster than using if statements. But here's the thing. If you stress out worrying about which of these is going to be faster, I don't know. The thing about code is most of the execution, most of the CPU time spent executing your program is going to be spent in a very small percentage of your code, a very small portion of your code. So if you waste a bunch of time and you waste a bunch of resources optimizing code that isn't in a performance critical section, you're just wasting everyone's time and you're probably writing code that's much more difficult to maintain because optimized code is generally not as simple and elegant. So you really gotta fucking pick your battles. And as a beginner, you're not gonna have a sense of where those battles are. So just forget about that shit and concentrate on writing solid code. Because honestly, even for advanced programmers, that is 95% of the battle. The optimization shit is such a small part of being a good programmer. And I love optimization. I love low-level bullshit. Don't get me wrong. I'm all about that shit. But you gotta understand that it isn't the real battle. The real battle is creating a complex system that doesn't implode on itself with like spaghetti coupling between all your different components and everything gets into a tangled mess and you're fucked. That's the real battle. So forget about thinking about, stupid micro-optimization bullshits that probably aren't going to matter anyways. Focus on writing solid code, and then when you got something working, then you can identify, okay, this is running slow, which routines are actually slowing it down, where's it spending the most time, benchmark that shit, get measurements, and then look at the problem routines and see how can I make it faster. First, you look at your algorithms, you look at your high-level concepts, see if you can cut out redundant work or do things in a smarter way, and then you start looking at the low-level bullshits of how to optimize shit, doing SSE, doing multi-threading, And one last thing is just make sure before you do your performance test that you're building it in release and not debug, because measuring shit in debug is just stupid. It's way slower. It doesn't make any goddamn sense. So before you say, this is running slow, I need to get my optimize on, make sure you're actually running it in release first. Here's a routine written more or less in straightforward C++ code. Here's the same routine micro-optimized. Now, which of these fuckers are you rather gonna want to be dealing with? Which one are you gonna rather write? Which one are you gonna rather want to debug? So stick to writing a solid code base and only worry about these performance issues when they actually become a real issue, which shouldn't be all that often when you're just working out as a beginner. Anyways, that's my 2 cents. 40% of you are probably going to ignore me and do a bunch of dumb bullshit anyways. And that's okay too, you know. You learn a lot just by making dumb mistakes as well, so I ain't going to hold you back. You'll eventually come around, trust me. For the homework, what I'm going to get you guys to do is take the ideas that I've shown here in tutorial 22 and try to apply them somewhere in Arpanauts. There's one or maybe two places where I think that they can fit in fairly nicely. But I'm not going to tell you exactly what you should change. That's for you to try to figure out. That's part of being a programmer, right? And I will be there with the solution video to show you what I think could be a good candidate for being converted to enumeration in Arpanauts. But until then, I hope you enjoyed the video. If you did, please click the like button. It helps a lot. And I will see you soon with some more C++.